So Simpson's rule, we got our delta x, which was 1/4. Divide by 3. We need to alternate the internal terms between 4 and 2. N has to be even, which gives us an odd number of endpoints. So the endpoints were starting at 2 and then going up by 1/4. So that was 9, 11, 12, 13, 14, 15, and then finally that gets us to 4. And this here is just 3. So we plug in 2 cubed, and then 9/4 cubed, and then at the very end 4. There we go. Did you hear me say anything about a mixing problem? Did you hear me say anything about any work problems or any differential equations? That should answer your question, Jimmy. Alright, find the volume of revolution generated by rotating the area bounded by 3x squared and x about the x-axis. So, roughly 3x squared, x, something like that. So, about the x-axis, it'd be down here. So we would cut a little slice, and it looks like a washer. So we have our pi. We need our outer radius squared, which is x, minus the inner radius squared dx. And then we need to know where they're equal. So looks like 0 and 1/3. So this would be x cubed over 3 minus, this would be 9. That's going to be x to the 4th, and then when you integrate, it'll be x to the 5th over 5. From 0 to 1/3. Nice thing is when we plug 0, it goes away. So we just got to plug in 1/3. So 1/3 cubed over 3. That's just going to be 1 over 3 to the 4th. And 9/5 times 1/3 to the 5th. So it looks like pi times 1 over 81. And what's this going to be? pretty small area. So that was number 3. I think somebody also wanted 4. So let me do that one. So this one, rough sketch, we need to find out what does x minus x squared look like. And I want to say from my memory yesterday, it looks something like this. And then you rotate about a point, so then it's over here. And so you're getting cylindrical shells. Alright. So shell method is 2 pi integral. The x equals 0, y equals 0 just tells you that this is the only piece that we want, by the way. The distance to the slice is x, always. The distance out to the rotational axis is 5 in this case. We need the radius, which is going to be 5 minus x, times the function, x minus x squared. That's 2 pi RL. And our bounds, we just need to find out when does this thing cross the axis. And so clearly it's 0 and 1. Multiply this all out before integrating. So this is 5x. We're going to get minus 5x squared minus x squared plus x cubed. And Okay, so that's number 4. I did do 1C yesterday, but I can do it again if you like. I got all screwy. Great. Oh well. Alright. This is a trig sub, and you've got a number minus x squared, which means we're going to want to use 1 minus sine squared here. So x has to equal 4, come on cursor, 4 sine theta. That tells us that dx is for cosine theta, d theta. So if we plug that in, then we've got 4 sine theta cubed, the dx, which a lot of people tend to forget, all over square root 4 sine theta squared. So I'm going to write that as 4 to the 4th out in front. Right, there's 4 cubed, and then another 4 up there. Then you've got sine cubed cosine d theta, and on the bottom that is 16 minus 16 sine squared. So we can manipulate this in here. This is going to be 16 times 1 minus sine squared, which is equal to 16 times cosine squared, or 4 cosine, when we take it out of the radical. So 4 cosine squared. So I currently have 4 to the 4th integral sine cubed cosine, and I have the square root of 4 cosine theta squared. That can come out. Cosines would cancel. So would one of the 4's, leaving the 4 cubed out in front. So I've got 64 integral sine cubed. So this is now a trig integral, and I would change that to sine times sine squared. And so that's the same thing as 1 minus cosine squared. And then let's go ahead and break it up into 2 of them. They look like that. Each can be solved. Integral of sine. It's going to be minus the cosine. And then the second one, let u equal cosine. I'm going to steal this negative and put it back in here because du is going to be minus the sine. So this becomes plus. That would be integral of u squared du. That becomes u cubed over 3. So that's cosine cubed over 3 plus c. But unfortunately, we're still not done because we've got to use our good old trusty triangle. We had x equal 4 sine theta, so sine of theta is x over 4. This side is 16 minus x squared, and that's a good sign because that was in our original problem. Therefore, the cosine of theta here is the square root over 4. So this is equal to 64 minus the radical plus the whole thing cubed. And you could multiply the 64 in. The final answer might be a derivative of that. One of these is fine. You could definitely simplify that. This thing got all screwed up. What happened here? Yeah, I don't know. You could simplify it slightly, but I'm happy with this if you get that far. Honestly, I'm pretty happy with this as well. Although you should be able to simplify stuff at this point. On problem 6, is the x the length of the spring or the change in the length of the spring? So again, I don't remember telling you I'm going to give you any work problems, but a spring with a natural length of 20 centimeters is stretched to a length of 46 centimeters or 45 centimeters. How much work would it take to stretch the spring? So the 1/2 kx squared, x is the amount of stretch from equilibrium. So work is 1/2 k x2 squared minus x1 squared. So that's 1/2 k times, in this case, how much work would it take to stretch the spring to 53? Well, that would be 33 centimeters over, and x you'd put in meters. So then, I guess if you're starting at the natural length, that would be 0 squared. Alright guys, what other problems would you like to see? Okay, so we didn't do those. Yes, I am recording. I hope I hit record. Yeah, recording. 1e. Let's see. How do we break up tan to the 5th? We need either u to equal tangent and du to then be secant squared, or we would need u to equal secant and du would be secant tan. Right, those are our options for tangents and secants. Okay, so we have to break up this tan to the 5th in order to get one of these two things, right? So I'm thinking maybe tan cubed times tan squared. That'll make it tan cubed times one. That's what, secant squared minus 1. So I'm basically breaking it down into two integrals. And it looks like I'd actually have to do it again here. So this one you can u sub. This one, I'd have to do the same thing. So then I would let u equal tan and du is secant squared. So this would be u cubed du. This one here would be u du. And the last one you would just have to either recall or you have to plug in sine theta over cosine theta to solve for it. So that one is that natural log secant, I believe. So u to the 4 over 4, where u is tan. And then you'd have to plug in the bounds, which were 0 to pi over 4. But you can do that. Hard part's the integral. Was that helpful, Jimmy? And that's not necessarily the best way to go about doing the problem. That's just how my brain broke it down. Any other problems you guys want to do? Maybe have time for one or two more, and then I definitely want to set up the Teams thing so I can make sure you guys all have a chance to sign in. Number 7. Arc length. Alright, so arc length is going to be an integral, and it tells us the bounds 0 to pi over 4. We need square root. We need 1 plus h prime here is going to be the derivative of this, which is 1 over the inside times the derivative of the inside, and that's minus the tangent. So let's see, that's going to give us 1 plus tan squared in here, and that, I believe, is secant squared. So this will be integral secant, and that's one that you got to do by parts, if I remember correctly, or you can remember this. Well, would be a plus c, but we don't have a, come on. How's that? The other way you could do that one, remember, was, and I know I showed you guys this in class, you can multiply it by secant x plus tan x, top and bottom. Keep doing that. And when you do that, you get secant squared plus secant tan, which is the derivative of the bottom. And so you get the natural log of stuff out of that. That helpful? No problem. All right. How about one more? And then I want to get you guys set so that there's no confusion come test day. 17. Evaluate the limit using the series. Okay. So we're given e to the x here. Then we can write out the first couple terms. Right. So when n is 0, we get x to the 0 over 0 factorial, or 1. And then we get x to the first over 1 factorial. And then x squared over 2 factorial. And I think that'll be enough. Let's see. So that's 1 plus x squared over 2. Now we also need to plug in for e to the minus x, which is going to be a summation just like the other one, but it's going to be negative x to the n over n factorial. So first couple terms there, we get negative x to the 0 over 0 factorial. That's still 1. Negative x to the first power is going to be minus x, and then divide by 1. Next one's going to be squared, so it'll still be positive. And I think we'll just need those 3. So plug them all in. So this is now limit x approaches 0. We've got 1 plus x squared over 2 minus 1 minus x plus x squared over 2 all divided by x. So let's see, the 1's will cancel, the x squareds will cancel, and we'll actually have 2x over x, which turns out to be limit of 2, which is 2. Yep, that's good. So that one went pretty fast. Anybody, or you have one more that you'd like to do? Oh, you would pick the longest problem on here, wouldn't you? All right. So let's see if we can get through this. We're going to do a ratio test. So we need limit and approaches infinity. All must be less than 1. Okay, so let's see, the 3 to the n will cancel with the n. This 3x minus 2 to the n will cancel with that n. And rewriting. That's what's all is left. This has no bearing with the limit, so it could go out there. And the limit of this guy, if we divide through, right, it'd be 1 over n, or should be 1, 1, and 1 over n. That's going to go to 1. So then we've got 3x minus 2 over 3 must be less than 1 and negative 1. Why did my pen stop working? Alright, so then multiply through by 3. Add 2. Divide by 3. So that should be my interval. I just got to test the endpoints. So left, so this would be 3 times a negative 1/3. So it's going to be negative 1 minus 2. It would be minus 3 to the n over n times 3 to the n. And that's going to be, if we simplify, negative 1 to the n over n. That's an alternating series. So you would need to prove that it's decreasing. So 1 over n. And the one thing I noticed is you guys just automatically think everything looks like this, because just about every problem I did looks like that. So like on the last test, I think it was like a function that actually looks something like this. So you gotta at least plot the thing similar to what it looks like. So this would be 1 over n, because you would take the absolute value and the negative 1 to the n would go away. We know what 1 over x looks like. It looks like that. So that is decreasing. And then we would need the limit as n approaches infinity of 1 over n. And that very easily goes to 0, because you'd have 1 over infinity. So that converges, which means we include that point. And then we do the 5/3. So plug that in, you get 5 minus 2 would be 3 to the n. So we get 3 to the n over n times 3 to the n. These 3 to the n's cancel, and you should automatically notice this series as the harmonic. So it diverges, and we do not include the other end. So you should have this and that. Did that help? I hope. Cool. All right. So if you guys don't mind, I mean, if you have more questions, that's great. But let's go ahead and let me let's try to set up the